Good everyone, my name is Tutor Dan and I'm your tutor for today. Please do well to subscribe and follow us across all social media pages at Gordon School of Mathematics. In today's class, we're looking at the topic basic operations in standard form, such as addition and subtraction in standard form. We're also looking at multiplication and division in standard form, right? So we know that numbers in standard form are of the form a times 10 raised to power n, where a is greater than 1 but less than 10, right? And n is an integer, right? Let's just say that n is an integer. That is, it can be positive, it can be negative. If n is positive, then it is a whole number. If it is negative, then it is a decimal number, right? Now, to add or subtract in standard form, the first thing you must note is that number one is that the indices, right, that is n, right, the indices of the two numbers must be the same. Right? And then number two, all we just need to do is we have a times 10 raised to the power n plus, let's say, b or another a, right, times 10 raised to the power n, right? First is that their indices must be the same, and then we then add the what? The front numbers. Number two, add or subtract the front numbers. That is a, right? You add the two a's. Then number three, you must now check that your answers are, your answer is in correct standard form. What does that mean? It simply means that your a must be greater than 1 and must be less than 10, right? That is, a must not be less than 1 and must not be greater than 10, or a must be greater than 1 but less than 10. So to add or subtract any number in standard form, two numbers, for example, in standard form, right, is to first ensure that their indices, that is, their n, are the same thing. Number two, you add the two front numbers, that is the two a's, add them together. And then number three, you have gotten your result, but you need to check that your result is in correct standard form, right? Examples: calculate number one, 3 times 10 raised to the power 4 plus 2.6 times 10 raised to the power 4. Number 2, 5.6 times 10 raised to the power 6 plus 4.2 times 10 raised to the power 5. Number 3, 5.6 times 10 raised to the power 6 minus 4.2 times 10 raised to the power 7. Now, solution number 1, we have 3 times 10 raised to the power 4 plus 2.6 times 10 raised to the power 4. Now, the first thing you need to check is if their ends, that is their indices, are the same. If the indices are the same, then we can then go ahead to add the two front numbers. That is, we have 3 plus 2.6. And then, of course, we just pick one of the 10 raised to the power 4, right? And this gives us 5.6 times 10 raised to the power 4, right? This is our result. Before we conclude that this is our result, we need to first check if it is a correct standard form. That is, this is our a. Is it greater than 10 or is it less than 1? Now, 5.6 is definitely greater than 1 and it is less than 10. So it is a correct significant what? It is a correct standard form. So number 2, we have 5.6 times 10 raised to the power 6 plus 4.2 times 10 raised to power 5. Now, if you look at this, their indices are not the same. Now, if their indices are not the same, that is n, right, we cannot go ahead and add the front numbers. We need to first make their indices the same. We either make the two indices 10 raised to power 6, or we make the two indices 10 raised to power 5. Whichever one you do, right, will give you your results. Now, for purpose of explanation, I'm going to make the two indices 10 raised to power 6, and I'm also going to make the two indices 10 raised to power 5. Now, first, to make the two indices, make the indices 10 raised to power 6 first. Right? Now, to make the indices 10 raised to power 6, it means that I need to add 10 raised to power 1 to 10 raised to power 5, right? To make 5, 6, I need to add 1. Is that so? Now, which means I need 10 raised to power 5, 10 raised to power 1 to make 10 raised to power 5, 10 raised to power 6. Now, how can I achieve 10 raised to power 1, right? It means that at this point, n is positive. Is that so? Now, remember that if I have 42, for example, if I shift the place of my decimal point backward one time, that will give me 4.2 times 10 raised to power 1. What does that mean? It means to achieve 10 raised to power 1, all I need to do is to shift the place of the decimal point backward. So if I have 4.2 times 10 raised to power 5, and I shift the place of the decimal point backward one time, right, this will give me, we now have 0.42, which is 0.42, right? Times the 10 raised to power 1, I shifted it backward, right? Then times this 10 raised to power 5. This will give me 0.42 times 10 raised to power 1 plus 5, according to indices, which is 0.42 times 10 raised to power 6, right? So now, we now have this second number to 10 raised to power 6. We've raised 10 raised to power 5 to 10 raised to power 6. So their indices are now the same. 4.2 times 10 raised to power 5 is now the same as 0.42 times 10 raised to power 6. So the question is now 5.6 times 10 raised to power 6 plus 0.42 times 10 raised to power 6. Now that their indices are the same, we can now go ahead and add what the front numbers, right? And then we pick one of the 10 raised to power 6. This gives us 6.02, right? And then we have 10 times 10 raised to power 6. Now, 6.02 is clearly correct standard form because it is greater than 1 and it is what? Less than 10. Now, let's resolve it now. But we need to bring down 10 raised to power 6 to 10 raised to power 5. Whichever one you use, right, will give you your answer, will give you your correct answer. You can either bring down 10 raised to power 6 to 10 raised to power 5, so that both of them will be 10 raised to power 5, or just as we just did, you raise 10 raised to power 5 to 10 raised to power 6, right? And then both of them will be 10 raised to power 6. Now, to make both indices 10 raised to power 5, right? It means that I need to subtract 110 from 10 raised to power 6 to get 10 raised to power 5, which means I need to achieve 10 raised to power minus 1, right? Now, and then, which means my n will be negative. That is, if I have 0.5, for example, I shift the place of the decimal point forward one time, that will give me 5 times 10 raised to power minus 1. Which means to achieve a 10 raised to power minus 1, the place of the decimal point will move forward one time. If I am to achieve 10 raised to power minus 2, it means my place of my decimal point will move forward 2 times. Now, what does that mean? It means that my 5.6 times 10 raised to power 6 will have to move forward one time for me to be able to achieve 10 raised to power minus 1. That will not give me, the decimal point I've moved from this place to this place, this will give me 56 times 10 raised to power, since it moved forward one time, that will be minus 1. then this times 10 raised to the power 6. This will now give me 56 times 10 raised to the power minus 1. According to law of indices, times change to plus, and then we have 6. And this gives me 56 times 10 raised to the power minus 1 plus 6 is 5, right? So their indices are now the same. 5.6 times 10 raised to the power 6 is now clearly 56 times 10 raised to the power 5. We now have 56 times 10 raised to the power 5, right? Plus 4.2 times 10 raised to the power 5. Now, since their indices are now the same, what do? I go ahead to sum up their A's. So we have 56 plus 4.2, right? That will pick one of the 10 raised to the power 5s. And then we have times 10 raised to the power 5. Right? 56.42 will give me 60.2. Right? Then times 10 raised to the power 5. Now, we cannot leave this as our final answer, because if you look at A is clearly greater than 10, which must not be. Now, we need to make A correct standard form, which means A must be greater than 1 and less than 1. Now, if I move the place of the decimal point forward, I will have a minus, right? And then I will have 602, which is clearly greater than 1, which means my place of decimal point cannot move forward. It will only move backward. Now, if I move backward one more time, it means that I will now have 6 points, right? 6 is clearly greater than 1 and less than 10, which will now give me 6.02 times 10. Since it moves backward, it's positive, times 10 raised to the power 1, then times 10 raised to the power 5. This will now give me 6.02 times 10 raised to the power, according to law of indices, we have 1 plus 5, which is 6.02 times 10 raised to the power 6. Now, whichever one you did, whether you make the two indices 10 raised to the power 5 or you make the two indices 10 raised to the power 6, you still get your result. What does that mean? It means to add or subtract numbers in standard form, number one, you must first ensure that their indices are the same. Now, when we've confirmed that their indices are the same, we now go ahead and add the two front numbers and pick one of the 10 raised to the power, one of the indices, right? And then number three, you must ensure that your result or your answer is in correct standard form. All right. So number three, we have 5.6 times 10 raised to the power 6 minus 4.2 times 10 raised to the power 5. So the first thing we want to do is to ensure that their indices are the same. That is, we either make the two indices 10 raised to the power 6 or we make the two indices 10 raised to the power 5, right? Now, whichever one you do will give you your answer correctly. However, for purpose of explanation, I'm going to make the two indices 10 raised to the power 6, get the result, and I'm also going to make the two indices 10 raised to the power 5, and then we get the result. Now, make the two indices, 10 raised to the power 6. Now, which means I'm making 4.2 times 10 raised to the power 5, I'm raising it to 10 raised to the power 6. And to raise 4.2 times 10 raised to the power 5 to 10 raised to the power 6, right, I will need to add a 10 raised to the power 1, right, to make it 6, which is positive. And if it is positive, it is whole number, it means the place of my decimal number will move backward one time. So this will give me 0.42 times 10 raised to the power, it moved backward one time, then times this 10 raised to the power 5, right? So this will give me 0.42 times 10 raised to the power 1, according to indices plus 5, which is what? 0.42 times 10 raised to the power 6. Now, their indices are now the same. We now have 5.6 times 10 raised to the power 6 minus 0.42 times 10 raised to the power 6, right? Now, we will now have, what do? We then go ahead to subtract the two A's, that is the two numbers at the front. We have 5.6 minus 0.42, right? And then we pick one of the 10 raised to the power 6. Of course, We have 5.60 minus 0.42 will give us 8, 1, and then, of course, 5. So this gives us 5.18 times 10 raised to power 6. And this is our answer because our A is greater than 1 and it is less than 10. So it is a correct standard form. Now, let's make the two indices 10 raised to power 5. That is, we bring down 10 raised to power 6 to 10 raised to power 5, so that the two of them will be 10 raised to power 5. And then we subtract the two A's and see if we will get 5.18 times 10 raised to power 6. 10 raised to power 5. Right? So which means to make 5.6 times 10 raised to power 6, 10 raised to power 5, we will need to subtract 110, which is 10 raised to power minus 1. Is that so? Which means clearly, instead of going backward, it will go forward. And this will give us 56 times 10 raised to power minus 1, then of course, times 10 raised to power 6. Right? And this will give us 56 times 10 raised to power minus 1 plus 6, which is 56 times 10 raised to power 5. Minus 1 plus 6 is 5. Right? Now, their indices are now the same. The question is now 56 times 10 raised to power 5 minus 4.2 times 10 raised to power 5. What do we do? At this point that the indices are the same, we subtract their what? Their A's. We have 56 minus 4.2, right, times pick one of the 10 raised to power 5s. Now, 56 minus 4.2 this is 8, of course this is 6.0, right? This is 1 and this is 51. So this gives us 51.8 times 10 raised to power 5. Now, this cannot be our result because 51.8 is clearly greater than 10. So it means that we need to make this a correct standard form. We shift it backward one time and this will give us 5.18. Since we shift it backward, it's a positive times 10 raised to power 1. And of course, we have times 10 raised to power 5. And this will give us 5.18 times 10 raised to power 1 plus 5 according to indices, right? And this gives us 5.18 times 10 raised to power 6. So whichever one you change will give you your result. However, it's not compulsory you do the two, so you just choose whichever one. If you want to raise it up, the smaller index up to meet up with the bigger index, so that both of them will be the same, you can go ahead and raise up. If you want to bring down the bigger index down to meet up with the smaller index so that both of them will be the same, you also get the same result. So simply, for you to add or subtract numbers in standard form, number one, their indices must be the same. Number two, you add or subtract the two numbers in front, that is their A's. And then number three, you must check your result or your answer that it is a correct standard form, right? The next topic we are looking at is multiplication and division in standard form. Now, for example, unlike addition and subtraction, their indices, you are not concerned with whether their indices are the same or not. Now, to multiply or divide in standard form, what you need to do is, you see the two A's, multiply them, right? We have 4 times 10 raised to power 6 times 2 times 10 raised to power minus 4. Just put them in brackets. The two A's, bring them together. 4 times 2, right? Multiply the two A's, and then, of course, multiply the indices. 10 raised to power minus 4. So that 4 times 2 will give you 8. Then we have times 10 raised to power 6. According to indices, multiplication changes to what? Division. So we have plus, and this is minus 4. So that plus times minus will give us minus. So this gives us 8 times 10 raised to power 6 plus times minus 4, which is 8 times 10 raised to power 2, and this will be your result. Because you must also check that your result is a correct standard form, right? Number 2, we have 4 times 10 raised to power 6 divided by 2 times 10 raised to power minus 4. The same thing, divide your A's, 4 divided by 2, then Also divide the tens. 10 raised to the power 6 divided by 10 raised to the power minus 4. Right? 4 divided by 2 is 2, of course, times 10. We have, according to indices, division change to minus. We have minus, and then, of course, minus 4. And this gives us 2 times 10 raised to the power 6. Minus times minus is plus 4. So that this gives us 2 times 10 raised to the power 6 plus 4 is 10. And this is your answer. Now, it is a correct standard form because 2 is greater than 1 and it is less than 10. I hope it's clear. Do these exercises and leave your answers in the comment section, and I'll be there to tell you your mark, whether you are right or you are wrong. Do well to like and share so that others can benefit too. See you in the next class. Bye for now.